CNEH reports nominal status. Our SSR pointers are where we expect them to be, which means we've recorded the expected amount of data.
Copy that. Looks like we have a good data report. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
In 2015, the New Horizons mission changed our understanding of the solar system as it rocketed past Pluto, providing breathtaking, never-before-seen images of the dwarf planet in exquisite detail. Pluto becomes a known world, but nothing is quite as startling as the colors seen in this composite portrait. Blue, red, and infrared images resolve details as small as 0.8 of a mile.
Pluto's far more active and diverse than even my imagination said it was going to be. That's okay, because, every time we've gone to a new place, we always find our imaginations are never up to the task.
24 hours after passing through the Pluto-Charon system, New Horizons is nearly 1 million miles behind the planet, making its way toward its next target, the Kuiper Belt object designated as Ultima Thule, what scientists believe to be a potato-shaped chunk 45 kilometers across, likely similar to the Plutonian moons Hydra or Styx. But it won't be until New Horizons arrives at Ultima Thule that its true shape will be revealed. The rendezvous with Ultima Thule is set for January 2019. By then, New Horizons will be another 1 billion miles from Pluto. By 2017, New Horizons was deep in a realm of far-flung chunks of ice. But what is this new region? Science now divides our solar system into 3 zones. The innermost planets, Mercury, Venus, Earth, and Mars, are small, rocky, and close to the Sun. This is the first zone. The second zone is the domain of gas giants, Jupiter and Saturn, Uranus and Neptune. Tiny Pluto marks the outer edge. Yet, astronomer Gerard Kyper predicts the existence of a belt of icy bodies that lie beyond Neptune, girdling the entire solar system. A vast flattened plain of icy bodies, now called the Kuiper Belt.
The power levels and, dealing with some other technical challenges conspire to make this a tougher and riskier flyby.
Mm-hmm.
In fact, there's one shot I want to tell you about. At closest approach, we're going to try to image Ultima at 3 times the resolution that we had for Pluto. If we can accomplish that, it'll be spectacular.
Wow.
But we've got to shoot at a moving target as we go by. We're going to fire off hundreds of images, hoping to capture it somewhere in that strip.
Wow. Yeah.
It requires extremely precise navigation, much more precise than we've ever tried before. We might get it and we might not. And if we get it, it's going to be spectacular.
3.5 years after revolutionizing our understanding of Pluto, the New Horizons spacecraft continues its journey into deep space. It's traveled 1 billion miles since rocketing past the dwarf planet. Cruising at speeds of almost 10 miles per second, the piano-sized craft beams back early pictures of Ultima Thule. And it's not a potato-shaped object as once believed. Instead, it resembles a snowman.
If you think about it by analogy, New Horizons is going to the farthest part of our solar system, and it is very cold and dark and barren out there. So unlike an asteroid, which is actually just a piece of rock that is melted and changed over with some alteration by some internal water, Ultima Thule never melted, never differentiated, never made a core, even like our planet Earth has a core. All that stuff is just as it came from the galaxy, we think, and is just a random loose snowball accreted material. So we'll see if that's really true.
And on January 1st, 2019, New Horizons will ring in the new year by traveling back in time and studying the earliest days of our solar system.
The Kuiper Belt is the edge of our very solar system. It's the part of the original disk that the sun and the planets formed out of that's at the very edge before you just get into the galaxy and the region between the stars. And at that very edge of the disk, there wasn't enough stuff to make giant planets and make big stars like our sun. There was just enough stuff to make small dwarf planets and snowballs.
New Horizons will fly past the 20-mile-wide asteroid in a split second. But the images and the data beamed back to Earth will provide scientists with a lifetime of information.
Ultima Thule, we know very little about right now, but we think it's the most primitive object ever visited by a spacecraft. That's preserved what the material was at the time of the formation of the solar system.
If you were on board New Horizons right now, Ultima Thule would be about as big in the sky as a full moon over the Earth. So we're going to start the countdown. We're almost there. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Go New Horizons!
We've just accomplished the most distant flyby. We are ready for Ultima Thule science transmission at 200 UTC today. Science to help us understand the origins of our solar system.
That's it. Have you seen this before? Yeah. Ultima Thule has been sitting pretty much the same place, the same distance away from the sun for 4.6 billion years. It's relatively small in a very, very cold region of space. It's been well preserved. It's really, it's a relic of the formation of the solar system.
As data continues to reach Earth, Ultima Thule reveals its true shape, and earlier predictions are proven false. From the side, the snowman looks more like two lumpy pancakes, providing another clue to the mystery of our solar system's formation and evolution.
We know there was a period of time in the first billion years that this was a dangerous place to be, anywhere in the solar system. One epoch in the past of our solar system, the giant planets are all moving around. They're actually plowing into the original Kyper belt. We're only seeing the remnants of the Kyper belt right now. And Jupiter, Saturn, Uranus, and Neptune probably plowed into that and scattered them all over the place.
These scattered bodies caused numerous collisions, most small, some large, and in the case of Pluto and one other planet in our solar system, there was a collision big enough to smash the entire world. That other planet is Earth. And from the scattered debris, our moon was formed. Astronomers call this period the Late Heavy Bombardment. The abundant craters across the face of the moon are a testament to the violence of this epoch.
We think that these large-scale collisions between planets early in the formation era of solar systems are common. And in computer models, we see that happens a lot.
Here we've got clues out in the Kuiper Belt that indicate that's what happened.
That's one of the exciting things, is that we're looking at something that, although it's far from our Earth and far from our common experience, may actually be important in planetary science in other solar systems as well.